is the setup for a geometric sequence, right? This is year 2, so this is u sub 2. This would be 2 minus 1, which is 1, which is the exact same thing we just had before, but now it looks a lot fancier. But now we can show that, hey, this is what a geometric sequence looks like. We've just created fancy wrapping around this multiplication to make it look like and show you that it is this thing. So now that we've shown that it is a geometric sequence, we can pull out what is r. Well, r is 1.05, right? It grew by 5%. So your r would not be 5% or 0.05. It would be the growth of that. So 1 plus 0.05. It then said, calculate how much Laura will earn in her 5th year at work. So now this is when I have to really make sure that my notation matches what I mean it to be. If year 1 is u sub 1, then year 5 will be u sub 5. And that makes sense. We have set it up nicely here that it makes sense that that would be that, right? Sometimes it might be like before we even got 1 year in, so like year 0, initial value, right? That would be 0, u sub 0. And so we would have to do some calculations there to figure that out. But just always double check that your notation means what you think it means. That's a pause, assess within your problem solving process. So now we just get to use the formula. Right? Remember, n always matches with this guy down here. Go ahead and tell me what this is to 3 significant figures. We got something like this in our calculator, which 3 sig figs would become this. Okay, so an applied version of what a geometric series or sequence, is. Example 3 is definitely more of an analysis question, but in this class, we still get analysis questions. In the analysis class, they still get application questions, right? There's still a little bit of a mixture. It's just we have less analysis questions. Notice there's nothing applied here in example 3. It's just giving you values and saying, hey, puzzle it out. So the third term of a positive geometric sequence, when you've got something that looks like this, your plan step is really important, and how you plan is really important. So I'm going to write out a few things like what's said up here, right? The third term of a positive geometric sequence, that means r is positive, and I'll link back to why that's important when it comes up. A third term of a positive geometric sequence is 63. So u sub 3 equals 63. And you might stop there and keep writing, but this is something I want to encourage you to do. If we have a formula for the value that you have, write out the blank formula next to that value, right? If u sub 3 is 63, and we have a formula for finding any u sub n term, write out that formula next to that value, right? We would have found u sub 3 by doing u sub 1 times r to the n minus 1. But we know what n is because it's the third term, right? So we actually can do 3 minus 1, which is 2. So by automatically writing that out, I've automatically established a relationship. Hey, my common ratio, which we haven't even got to that part in the sentence yet, and my first term are represented in a formula which has some values in there already. So writing out a formula with numerical values that you have is a very important part of the plan step to help you visually make connections with what you need to do. So now I could do the 5th term, which is 567, and that equals u sub 1 times r to the n minus 1. N is 5 minus 1 is 4, so that's to the 4th power. So I want to find 2 things, a common ratio and a first term. That's 2 unknowns. We have 2 pieces of separate information, which helped us create 2 equations. we have all the information we need in order to solve for these using a system of equations, which is awesome, except for one thing. This is not linear, right? We've been able to do our systems of linear equations in our TI Nspire or our TI 84 for this whole time. This is not linear. Why is it not linear? Because one of our variables has exponents on it. So if your variable that you're trying to solve for has an exponent on it, your systems of linear equations actually doesn't work. So we have to do this by hand, but don't freak out. And we only have to do it by hand for a little bit. Okay, so I have two equations. I'm going to take them out of my plan step and put them into my solve step so I can like kind of manipulate things around. So I've got 63 equals u sub 1 times r squared, and I'm going to put it inside the parentheses just because it feels better that way when I'm starting to manipulate things around. So I know that that fourth and that squared goes with the r. And I know that if r is negative, then I'll have to maneuver that around. So in order to solve for a system of equations by hand, we could either graph this and find the coordinate, right? We could do x and y. For TI Nspires, you could do that. But I would encourage you to solve this by hand. And we could do this by substitution, right? Isolate for one of the variables, plug it in for the other one, and then solve. Trying to work smarter, not harder. Look at this and say, which of the things am I most excited or most able to isolate for? And that is u sub 1, right? I don't want to have to undo the squared piece with r in order to isolate r. I don't have to undo that fourth power there in order to isolate r. U sub 1 is pretty straightforward. I just divide by r squared on both sides. So u sub 1, because I divided both sides by r squared, is 63 over r squared. And I just put u sub 1 over here because it looks nicer for me. And I did the same thing with this guy. So if it's super easy to isolate for u sub 1, which it always will be for these types of problems, then now I've just said, okay, u sub 1 is this, and u sub 1 is that. And if u sub 1 is the same number, which it is, right, the first term of this same geometric sequence, then these two must be equal to each other. And from here, that's the only thing I have to do by hand. From here, I can do numerical solve. When you numerical solve, you get one value. And there's actually more than one value that is correct here. If I was to solve by hand, you would get, essentially, you would come out to r squared equals 9. We don't have to, if you feel like you can do that by hand, awesome, check yourself, see if you've still got this ability. But then you would take the square root of both sides and you get plus or minus 3. And this is why it was important that they said positive. If you did numerical solve, notice it's just said, hey, it's 3. It only gave you one value. The danger of numerical solve, but typically in this class, they try to make sure that it's, if you do use numerical solve, it'll kind of work out that way nicely. Okay, so we found the common ratio. The only thing we need to do is find the first term. Sorry. So all we have to do, first term is represented by this equation. It's also represented by this equation. Doesn't matter which equation we use. We just have to plug r in for one or the other. And we get that our first term is 7. You might get problems that look like this that don't say find the common ratio in the first term, but say instead like find the 30th term. And you would have to find these two things before you could find the 30th term in an IB test question. They would probably label it out like step by step. First find these two things and then find the 30th term would be like a very common follow-up question after that. So it can definitely grow into other things, but this is the process that's the most tricky. And so that's why we talk about it in this class. If we pause and assess for our plans, solve, assess, and problem solving, I'm going to just double check if this makes sense. Multiplying by 3 is 7, being our first term. If our third term is 63, 7, 21, 63, yeah, it's pretty easy to double check, pause, and assess to get me that third sequence. If you even continue to multiply by 3 So there's definitely ways you can just kind of pause and double check you did it the right way. If you feel like you have that time in a test, you always have that time when you're practicing. So definitely don't forget about the does this make sense? Okay, circling back to an applications type of problem. At 8 a.m., 1,000 milligrams of medicine is administered to a patient. At the end of each hour, the amount of medication that's left is 60% of that present at the beginning of the hour. So that percentage change, as we talked about earlier, that always means, hey, that's a geometric sequence. So then it asks what portion of the medicine remains in the patient's body at 12 noon if no additional medicine has been given. So we've got a 60% remaining, which will be our R. Before, when we said there was 5% more each time, we had to do 1 plus 5%, which got us 1.05. But notice the way that this is phrased here is that the amount present is 60%. So it's going down as time goes on. Think about it in context, right? As time goes on, the medicine that's in your body becomes that it dissipates and goes away. It is 60%. It's not going down by 60%, right? It's not decreasing by 60%. Each time, it's 60% of what it was before. So R is just 0.60. We don't have to subtract from 1, add to 1, because of how it's phrased. And be very careful. You can see how we would miss this tiny little word is. Okay. U sub 1 is our first term, which is 1,000. And I have to think, okay, this is what U sub 1 is at 8 a.m. So if I want 12 noon, that is 4 hours later. So I would need to do plus 4, right? If this is 0, or if this is 1, 9 would be 2, 10 would be 3, 11 would be 4, and 12 would be 5, right? Or you can just do 1 plus 4 is U sub 5. But you have to always check in with what does your notation mean and be consistent with that and how you use this formula. Okay, so we just need to find U sub 5, which now that we've established what we're looking for here, pretty straightforward. So you can go ahead and calculate for that. And we get 129.6 milligrams. Part B is a little bit harder and a little bit more interesting. So a second dose of 1,000 milligrams is administered at 10 a.m. Okay, so we kind of different system. What is the total amount of the medication in the patient's body at 12 noon? I think I actually want you to try and figure this out on your own. This is a challenging problem. And this is what we're here to practice as mathematicians and as math students is how do we get through a challenging problem? I would recommend a few things. Try to make a visual representation of what's going on. Can you make a timeline? Can you just draw little stick figures? Sometimes just that helps put you in the context of that. Connect that with the formulaic perspective on this problem and see if you can make the connection between the visual perspective that you're drawing out, the formulaic perspective that you're writing down, and maybe even put down a few example numbers. Even just try and brute force your way out of okay, what's happening at 9? What's happening at 10? What's happening at 11? What's happening at 12? And see if you can kind of figure this out and see if you can figure it out in a numerical way, in a visual way, and in a formulaic way, shifting your perspective to help you be a better problem solver. Okay. Great job today. I'll see you in class.